Welcome to part 11, Interactivity using Callbacks. Our layout is now complete and we are ready to begin the interactivity. If you recall, a Dash application is composed of two pieces, the layout and the interactivity. So the layout is where we place the components of the dashboard, and the interactivity is code that will change parts of the components of the dashboard whenever some event gets triggered. So this triggering event is usually some click on the dashboard, like a click on a button or on a drop-down menu or on a part of a data table like we'll see below. So one thing to note that is important is that this code, this interactivity code, must appear after the layout is set. So after we write app.layout equals layout, then our code for our interactivity can appear below that. If it appears above that, then you will get an error. So this code is just a bunch of functions that are called callbacks, and we're going to see an example of one below. And the way to write one is pretty tricky. This is probably one of the most complex pieces of Dash is the callback, so it'll take a while to understand. But the way it works is that we will be using this app.callback decorator. So a decorator is something that kind of wraps a function and needs to be placed directly above a function using this @ symbol. So this app is our variable name for our application, which we've already seen. And the callback method, this decorator, it takes 3 arguments. So we have 3 separate lists over here, and I'm going to talk about each one. So it takes in the outputs. So outputs, these are a list of the components that will be changed. So we want to change these components whenever our event gets triggered. And in order to label these components or reference these components, use this output class, which we will import from this dash.dependencies module. So you'll see that coming up when we write our actual callback below. And the arguments for the output is how you reference the particular thing you want to change, the particular component you want to change. So in this case, you have to give it an ID. Well, you always have to give it an ID and the targeted property. That's how you set each of one of these, the outputs, inputs, and state, is with the ID of the component and then the particular property of that, of that component. So we're going to look at the cumulative graph component, which is, if you recall, that dcc.graph component, and then all those dcc.graph components have a figure property, and that is ultimately what will get set. So we're targeting this very specific, property of this component to change whenever our callback is invoked. Okay, so what this callback does is saying, hey, we want to change these 3 figures, the cumulative graph, the daily graph, and the weekly graph. Each of them have a figure property. The figure property is a plotly graph. So that is ultimately what will be changed. We want to give it 3 new plotly figures for the output. Okay, and that's what you'll see down here below. So however many components you are changing, so here it's 3, that's how many return values you need. So here's the function that will get invoked. And I didn't write the code for it just yet, so we're just going to pretend there's some amount of code that will get executed. But what is important here is that what is returned. So the number of things returned, the number of items returned, must match the number of outputs that you say will get changed. So this aligns, these 3 align with these 3 figures. So figure 1 will be the new cumulative graph, figure 2 will be the new daily graph, and figure 3 will be the new weekly graph. Now, the next argument to this callback is going to be a list of inputs. So in this case, we're going to have one triggering event, okay? And we're going to use this input class, and it works the same way as output, is that the first argument is the ID of the component you want to change. So we're going to change that world data table. That's what this identifies. It identifies the world data table on the left-hand side and the active cell. So whenever you click on this world table, then that will trigger this function. So you click on the table and it will send the active cell, that's the cell that you clicked on, into this function. Okay, so that'll be the first argument sent into this function, is this active cell. So it'll send that data and it'll get mapped to this world cell variable. And one thing to note is that the function name here is inconsequential. So it does not matter what this function is called. So here you can name it whatever you want, change area graphs. The parameter names also do not matter for your function as long as you have the right number of parameters. So you can also pass in, besides the input, you can pass in something that is not triggered. So some things that are not triggered, you want to get in data from some part of your dashboard. It doesn't matter what it is. So you have another table or another graph, another label, anything else you can pass into your function to use in order to process some of the data, right? So this is called the state of something. Like, so you want to have the state of the graph for whatever reason. You want to have the state of the map for whatever reason. In this case, we want the state of the data of the table. So again, we're going to use this world table ID right here. That's what we're doing right here, the same ID. But instead of using the active cell, we're going to pass in whatever the data is. And in this case, I will show you the difference between this derived virtual data and the actual data. So if you recall, whenever we created the data tables in Dash above, the data property was set to a list of dictionaries. So it's kind of weird. All the data is a list of dictionaries where each list or each item in the list is a single dictionary representing a single row. Now, the difference between data and derived virtual data is that derived virtual data is dynamic, and I think I put that down here below, which means that it changes whenever it's sorted. So the data is static, and we'll see the difference in that. So say we sort the data by like cases or cases per million, that'll mix up the order of the data. But if we passed in the data as the state and not derived virtual data, then we'll have the original ordering, not the ordering that the user will see. So that's why we have this derived virtual data parameter right here. Okay, otherwise data is just the original data that was whenever the user first loaded the dashboard. Okay, so our function will take in all of the inputs and all of the states. In this case, it's just 1 and 1, so it'll have 2 parameters. But you could have 3 inputs and 4 states, and then there would be 7 parameters that it would accept. And they align in the order of input and state. So world cell will take on this value of the active cell. World data will take in the value of the derived virtual data. So you have to be careful how they map. Same thing with the outputs. They map to exactly what you output down here, or whatever you turn down below. Okay, so let's take a look at an actual callback function down here. So the first thing to notice is that yes, you have to import these. Sometimes you don't need many functions you don't need a state. You just take in the input and output. So this is not necessary component. All right, so notice that, okay, our layout is going to be the same layout that we defined above. So we're not going to write all that code again. We just are going to presume that it is saved to some variable. We've set the layout, and then we can start writing our callbacks. So I just explained this this decorator. It's the exact same as what was above. Now we're going to see an actual body of the function. So this will be new. So we're going to accept that world cell. This is the active cell. And then this is that list of dictionaries. So you have to look in the documentation for Dash to say, all right, what does active cell actually pass to the function? Well, it is a dictionary with the keys of row and cell that are mapped to integers of the cell location. So let's go ahead and run this particular code here and launch our dashboard. I have everything smashed in together at a height of 500 pixels, and that's for a reason you'll see in just a second. Just so we can see some of this output. All right, so it's going to take in the world cell and world data. This is a dictionary, so it's going to get the row number. And it's going to use that row number to figure out what the country name is. So unfortunately, when you click on the active cell, it does not, this world cell, this input, unfortunately, does not give you the name of the value right here. That's why you have to bring in the data as well, or else we wouldn't have to do that. The idea here is that we just want this country name, right? We want the country name so we can update our graphs to that country. And just to show you that it works here, we can click on Brazil, it changes to Brazil. We'll click on India, it changes to India. It also has the daily for India, and the weekly for India, and so forth. So that's what this is doing. It's creating these 3 graphs given the country. So we want to get the country. That's the whole point, is getting the country. And you would think like, okay, if I clicked on here, the USA, that would be the active cell. But it turns out you only get the numbers like 00. So that doesn't help you get the country name. In order to get the country name, you need to get the whole data frame back, which is not a pandas data frame. It is a list of dictionaries. So what can help you out whenever you're building these callbacks is just to print out what it is. What did I accept? I don't, if you can't find it in the documentation, or maybe you're lazy or just can't remember, a lot of times it's good to just, all right, let's just print out what this is. So that's what I do here. I'm going to print out that actual world cell exactly. The row number, since I already know this, is how it works, is a dictionary. So I'm going to get the integer for the row number. The row data, so I'm going to actually use this data over here. This is that list of dictionaries. So I'm going to get the dictionary for that particular row number. So for the USA, it's 0. For Brazil, it's 1. India, 2, and so forth. I'll get that row of data. I'm going to print that out. And then I'm going to print the country, which is found in the, in this country part of the dictionary. Okay, so let's go ahead and look at this. We've printed it out. So every time we click, we'll get something printed out below. So we've clicked on it multiple times. And so here's the first set. And so the way callbacks work is that they get triggered immediately whenever whenever the dashboard is launched. So all the callbacks will get called. That's why this USA was first, even though I didn't purposely click on it. So here we have, it says row 0, column 0. So this is what I'm talking about. Like, you don't get the country name. You just get the row and column as integers. Then we extracted the row number. All right, so we need to figure out what row it is. Then we get the row data from the derived virtual data. So here's that dictionary of that row. And then ultimately we do get the country because we know it's stored in the country variable like that. And then, so we take the country, and let's take a look at a few more. So here's Brazil, row 1, column 0, and so forth. And then we click on India, and then again the USA. All right, so we get the country. That's what we're after. We're after this country name. We pass it to our create graphs function that we've already created before. So this is in the layout, and we talked about this in a previous video. And this creates a 3 plotly graphs. So we've already seen that, and that's what we return. So this will return those 3 plotly graphs, and they will get mapped to these, cumulative graph, daily graph, and weekly graph IDs, and specifically to the figure property, and then update the graphs like that. Okay, so I know that was a lot. It'll take a while to understand these callbacks, but this is a good first example that uses all 3 of these, the outputs, inputs, and states.